Hey,
Hey, Joe, can you hear me all right?
yes, sir.
All right, beautiful.
Hey, I like new background.
Yeah, yeah. I'm made the basement look like it's a normal setting. So you got your video up and everything. You're off the VPN.
Yeah, should be all set. Now,
Cool.
is this going to start automatically or are we already started?
Yeah, no, I basically started. So it looks like, yeah, Nick just said audio's clear on both ends. And then it says you're recording, so we should be good to go.
Excellent.
Yep. And then Paula is checking in here.
Yep, I see. We'll give it another
Let's give us a few minutes. We're going to get started here at about 2.
yeah, 5. It's 1:55 here.
Yep, you got it.
All right, I'm going to mute myself for a couple of minutes.
Sounds good.
All right, I'll give it one more minute before we get going here. All right, it's 2 o'clock. So good afternoon, everyone, and welcome to our first webinar, the first of many to come. My name is Gilles Bignolas. I am a technical services representative for LATICRETE International. I want to thank all of you for coming here this afternoon and spending a little bit of this beautiful fall afternoon with us. With me is going to be my good friend and colleague, Marcel Schoen. Marcel has been in the industry for about 15 years, and we were lucky enough to have Marcel join our technical services team about 4 years ago. Marcel is an utmost expert when it comes to moisture mitigation system, as well as self-leveling underlayments. So I'm pretty excited to have him here to present his content for us. Marcel, would you like to say hello real quick?
How's everyone doing? Thank you very much for joining. Hopefully this is, very insightful. You get some fuel for thought going into the weekend. And again, thank you very much for your time here on a Friday afternoon.
All right, thanks, Marcel. So before we get started, I'm going to explain the format of this webinar a little bit. So we're going to start with a PowerPoint presentation, then we'll go into a small Q&A session, depending on how many questions were asked during the PowerPoint. And then we will go into a product demonstration demo. So we have about 50 minutes worth of content to present to you guys, which should give us enough time to answer all of your questions, which, by the way, feel free to ask at any moment in time in the chat window here. I will be monitoring the chat window as well as Marcel, so we'll try to get everybody's question. But just in case we don't get to your question, please be reassured that we will get to you by email later on this afternoon. So again, I am also very excited to present this content. I think Marcel's going to be awesome. And I hope you find our webinar educational and informational as well. So without further ado, I'm going to let Marcel do his thing. You will find that most of our content is pre-recorded, so don't be afraid if I start sharing my screen with you guys and playing videos and such. Marcel, you ready to go?
Absolutely.
All right, I'm going to share my screen with everybody here, and we'll get going.
How are we doing today? This is Marcel Schoen with LATICRETE Tech Services. Just wanted to thank you for joining our moisture mitigation portion of our PTK webinars. Let's go over some of the things that you're going to learn about in this presentation. We're going to start by going over the basic concrete mix, placement, and curing. We'll get into some flooring issues caused by moisture in concrete, some of the sources of that moisture. We'll go over the industry-approved test methods to measure this moisture in the concrete. We'll get into the types of floor coverings that are moisture sensitive. We'll learn how to prepare the substrate properly to receive the moisture mitigation product. And we'll go over the installation techniques for moisture mitigation products before we get into the hands-on portion of the demo. All right, so what is concrete? Concrete at its basic level is a mixture of Portland cement, fine and coarse aggregate, and water. This mixture may or may not have added to it, depending on the mix, chemical or mineral admixes, air and training agents, and steel or plastic fibers even. Here's a good snapshot of actually what you're looking at. All right, so you can see the cement, fine aggregates, air, water, coarse aggregates, and admixtures. Again, at a basic 101 level for concrete design, water to cement ratio is going to be critical. Most of the water in the concrete is used to help place the material, and then the water not needed for the actual hydration of the cement in the concrete is going to be called the free water. One of the common problems that arises from moisture in concrete is going to actually have to do with that free water. So excessive water, as you can imagine, using the design of the concrete to make that easier to place, will in hand cause that concrete to have lower strengths and higher capillary action. Higher capillary action can contribute to higher amounts of moisture vapor working its way up through the concrete into the enclosed building envelope, which we'll get into in a little bit. And this is actually a good snapshot of hydration. You can see it's an actual chemical reaction between the Portland cement and the water that produces these crystalline structures. They almost form together like spider webs, interlocking with each other, and that's where you're going to get your strength in the concrete. So hydration is actually very important when it comes to concrete design. And as we mentioned, it's an actual chemical reaction between Portland cement and water that produces crystalline structures. Two of the common ones are going to be what you see right here. These are great examples because you're actually going to be able to see here the crystalline structures under these microscopic photos. One of the major things to point out in regards to the science of hydration is that it proceeds at a much slower rate when the concrete temperature is low. Temperatures below 59 degrees Fahrenheit, 10 degrees Celsius are unfavorable for the development of early strength. Below 40 degrees Fahrenheit, or 4.5 degrees Celsius, the development of early strength is greatly reduced. And at or below freezing temperatures down to 14 degrees Fahrenheit or minus 10 Celsius, little or no strength develops. Think about that in northeast climates, northwest climates where it's cold. A lot of these buildings are not shutting down until the temperature is right. So just keep that in mind when these types of slabs are being poured. So based on what we just learned, just a hypothetical question, do you think that they add more water to the mix to make the placement easier? Or do you think that they deal with putting less water in to help the structure of the concrete? In my experience, coming from a commercial construction background, I certainly know that they put the water in there to make it easier to place. They want to keep that schedule moving and keep that job going. Okay. So now let's get into the curing of concrete. This is kind of where these two things compound with each other and again makes for potential moisture problems when it comes time for finished flooring. All right, so curing. As you can imagine, this step is going to be crucial to the hydration of the concrete and allowing it to get to the proper strength and design that it was intended for the building. Two of the common ways that slabs are cured nowadays are going to be the wet cure, plastic sheet, more that traditional method. Curing compounds are getting very popular now, which you can see here. It's a spray that almost goes on, same effect. But again, no matter what method is used to cure, the idea is that you want to keep that moisture in the slab, again, allowing those crystalline structures to form and allow that concrete to become stronger and stronger as time goes on, which is great for the slab itself. But again, as we just mentioned, these schedules are going faster and faster, so they're trying to get back on top of these structures sooner than ever, put walls up, windows, get the place enclosed without doing the proper curing method. So here's a good example of what happens as this slab is curing. Liquid, vapor, it's always going to want to reach equilibrium. So as you can see here, the moisture vapor is in the slab. It's working its way up, and uncovered, it has somewhere to go, and this slab is going to continue to cure. Nothing really is going to affect that. The vapor has nothing to stop it from going out of the slab. The problem that these faster schedules are bringing to the table for the finished flooring is going to be that all vapor and moisture, things like that, are going to try to reach equilibrium. I always explain this like imagine spraying a bottle of perfume or cologne in the corner of a room. At the beginning, you're only going to be able to smell that in the corner of the room. But as time goes on, that vapor is actually going to move throughout the room and reach equilibrium in the space. So not after too long, someone across the room is going to be able to smell that cologne or perfume. This is where the problem lies when finished flooring comes into play. As you can see here, these moisture vapors in the slab, they have an exit out of the slab. They're going into the room and trying to reach equilibrium, which in hand is allowing that slab to continue to cure and dry out. Here's some other examples of how moisture is going to come through that slab. The first example I showed you was a new slab, so that free water of convenience is going to try to exit that slab after being poured. Here are some other options though. Negative hydrostatic pressure is a big one as well. So this could be actual water in contact with the bottom of the slab. So in older buildings, on the previous slide, maybe the vapor retarder is no longer intact, so moisture has an avenue to come through that way. Also, if that water table is high, that may build up on the side of the walls. You don't notice it inside, but it's essentially going to start building up and coming through that floor on the edges of the walls, or as you see to the right from below an existing slab through negative hydrostatic pressure, which I just explained. Long story short, no matter what it is, the water is going to freely move to the top of the slab by high head pressure throughout the capillaries of the concrete slab. Think of the concrete essentially being a very dense, very hard sponge. The concrete's going to use any available moisture to continue the hydration process and get harder and harder over time. In other words, concrete can continue to cure indefinitely when exposed to water. Negative hydrostatic pressure is a fairly rare occurrence and can be alleviated or dissipated by the use of sump pumps, foundation drainage, French drains, curtain drains, you name it, or even good landscaping practices. Just want to make you aware of the potential problems that it can cause. Okay, so all of that stuff moving through the slab is essentially going to be, in a nutshell, moisture vapor emissions, which is what we're getting at as far as the products that are an end result to mitigate these moisture vapor emissions. Moisture vapor emission can be defined as the moisture that passes through a concrete slab caused by slight pressure differentials between the exterior and interior of the slab. As we just went over, it's certainly a natural and necessary process for any concrete pour. But as you see here, the problem starts when you put a floor covering over it. So you see these vapors trying to come up through the slab. We have our adhesive, we have our moisture, which in hand can a lot of times lead to high alkalinity, which could be the kiss of death for the floor covering. This doesn't just end at floor covering either. This can also affect waterproofing membranes, epoxy membranes, polyaspartic coatings. Whatever you're putting over the top of one of these slabs, you should certainly be aware of moisture vapor emission. We'll get into this a little bit later in the presentation. That's why, though, it's very important to know whatever finished product you're putting over these slabs, you must know the manufacturer's recommendations for installing when there is moisture present in these slabs. Since the moisture vapor emission can not only affect these products during the installation, but it can also rear its head while the adhesive is curing, or even further down the road when tenants have already occupied the space, which could be much more costly down the road. Here's a great snapshot to show you what the problems could start to look like. You can see here you're going to get potential bubbling. These vapors are going to push through the floor. Again, now they're going to have nowhere to go, right? So they're going to build up under this floor covering, and eventually these vapor emissions are going to turn into almost physical water again and start pushing this flooring off of the concrete structure. So I know that was a very quick run through of the problems, the science behind this, the research, it's all out there. This is, again, just try to get you aware of it, make you know the basics of it. If you do step onto a job site, you can talk the talk now while you walk the walk, but certainly do more research. But again, this is just showing you that this is real. These are how these problems arise. Now let's get into how they won't affect your projects when you're actually on the job site. We always suggest that you want to address moisture problems sooner than later. So again, like I just mentioned, you're going to want to know what the finished flooring or the finished coating manufacturer is going to say about moisture. You're going to have to test for that moisture, and then you're also going to want to know how to mitigate that moisture. Again, I always suggest doing this sooner than later, so you're not just getting to the job site and realizing that there's a moisture problem, or you don't put the floor in and, like I said, the tenants occupy the space, and then you learn that there's a moisture problem down the road. It's going to be much more expensive for everyone involved in the project. So this is a great picture here. I love to show every time. I would think most people in the construction industry know about the change order versus the original contract. We're trying to avoid problems on the contract down the road. And depending on what type of projects you work on, I know flooring is usually one of the last ones, so the discretionary budget is usually gone by the time the painter and the floor guy get into the project. So again, bring this stuff up sooner than later, and we'll get into this a little bit further on in the presentation. Okay, so what are moisture-sensitive floor coverings? Wood flooring, as you can imagine, would certainly be moisture-sensitive. Vinyl tile, resilient sheet goods, those things are almost going to close these floors off, so that moisture has almost nowhere to go through those products. So those are a lot of times where you're going to see the bubbling and stuff like that occur. Carpet and carpet tile, definitely affected. Obviously, you don't want moisture soaking into those products. And then the adhesives as well, what we'll get into a little bit, cause a lot of problems with those carpets, carpet tiles, resilient goods, you name it. Pretty much any non-breathable floor, even including non-porous tile, is going to be affected by moisture. It used to be, prior to porcelain tiles and these large format tiles, which are much more dense and non-breathable, it used to be assumed that if you put tile in a project, you didn't have to worry about moisture. Those days are gone. Again, some of these thin porcelain panels, the gauge porcelain tile panels, are getting very thin and very large. Moisture is also a concern with those as well. Not to mention moisture is a concern with any product, especially say natural stone, something like that, which again we'll get into in a little bit. So what problems can these cause? These are great examples of what happens with these sheet goods, right? You can see here on the left, this is an actual sheet good floor in a gymnasium. This is a real picture. This is not doctored, okay? This is what moisture did under this. You can see to the right, this is more common to the right. These are going to be your typical bubbles. A lot of times you'll see here, it's going to be at the seam where the heat weld or the cold weld is made, and those are going to force those floors to start popping. Not a good thing when it's in a hospital or somewhere where it's high traffic, commercial space where it's a tripping hazard. So you can imagine this could be a nightmare on an actual project. So that's what it'll look like under sheet goods. Here's what it's going to look like a lot of times under VCT, resilient flooring, carpet tile, those types of goods as well. You can see here on the left that high moisture has caused the glue underneath to essentially re-emulsify. How does this happen? Okay, let's go over the quick history. Everyone says they've been in the flooring industry for 30 years, right? Well, 30 years ago, most of the glues had asbestos in them. Those black cutback adhesives, those could handle virtually anything. They were not highly affected by moisture. For good reason, with all of the green and the LEED stuff and the cleaner building and lean building methods that are common nowadays, we've gone to water-based adhesives most of the time. What happens when that moisture builds up under these materials? It's going to take that water-based glue and essentially, like I said, re-emulsify it back to the state that it was in the bucket. It's not going to adhere the tile down to the floor anymore. This isn't a fault of the glue. This isn't a fault of the flooring. This is directly caused from the moisture coming out of that slab. So again, address this stuff sooner than later. You can see here on the right, this is a good example, like I was saying too, the high pH come through these slabs sometimes as well when the moisture has nowhere to evaporate. So you can see here the free salts in that slab essentially built up under this. And again, it caused that adhesive to erode and not work anymore. And again, you can see here's a good example. The floor was pulled up before they prepped it to remove this stuff, because now they're going to have to mitigate the entire space for the moisture vapor emissions. You can see here just running your finger over the slab, we were able to get wet adhesive onto our finger. So again, here's another snapshot of how this is going to work, right? That moisture in the slab, going to try to reach equilibrium. It's going to keep trying to evaporate. Moisture is going to rise straight up, right? Some people are under the misconception that, okay, well, if you cover it, the moisture is going to go and gravitate toward the walls and it'll exit that way and it's not a big deal. That's not true. It's a myth. Moisture is going to want to go straight up. So again, you can see here, it's going to affect that adhesive and over time either degrade that adhesive or even start pushing that finished flooring off of the floor. And this is an example of a floor that was not even covered with flooring. This is an extreme example of efflorescence. Again, a lot of times could be attributed to that moisture trying to exit that slab from the bottom up, which causes this efflorescence to occur when these salts migrate to the surface of the Portland cement product using water as the vehicle or through capillary action like we explained at the beginning. As this water evaporates and the salts are left behind, it leaves this unsightly problem on the job. Like I alluded to before, there was always that belief and often that misconception that if you put tile down, moisture wouldn't be a problem. Here's an extreme example of efflorescence in a tile install. So it didn't blow this tile off the floor, which is a problem with, say, the carpet or the VCT that I showed earlier. But it grossly affected the appearance of the product, right? This can greatly affect, like you see here, tile installs, resinous floor finishes, fluid applied membranes, or other sheet membrane type products, anti-fracture, waterproofing products, for example. And in extreme cases like this, as you can imagine, carpet and carpet pad would be affected to the level of mold or mildew growth. Wood trim, stuff like that. So again, I know I sound like a broken record at this point, but it's always better to address the moisture sooner than later. So here's an example of what I meant before when I was saying always know what the finished flooring manufacturer says about moisture with their product, okay? Read the label, read the fine print. A lot of times you have to go digging for this. But these are 3 very vivid examples of how these different finished floorings want you to address moisture. So the top one here is an adhesive one, suitable for use with VCT over concrete slabs up to 90% internal relative humidity, when measured in accordance with ASTM F2170, the standard test method for determining relative humidity in concrete slabs using in situ probes. So you can see here, this is very direct language. It's recommending standards. And then the other ones on this page are essentially an extension of that or their own version of that. If you're a sub or something like that, or say a homeowner buys the material for you, don't just go there and assume it's okay to put in, especially say if it's in a basement or something like that. Take your time, read the label, and do what you have to do before it becomes a problem down the road. So just as a quick recap, it may be obvious stating that moisture is a part of concrete at this point, but considering the billions of dollars in damage that moisture intrusion or moisture-related problems can cause each year in the building and construction industry, it's worth saying again, concrete has moisture, and it must be addressed. So just as a quick recap, the situations described can occur in both closed and open systems. Closed system referring to a slab on grade with a vapor barrier, and worth pointing out, sometimes the source of moisture can be caused by something outside of the slab itself. As you can imagine, there's numerous other ways that moisture can be introduced into these slabs. For example, water supply lines. If there's a leak in a supply line somewhere, there could be a continuous supply of water going into a slab and very hard to detect. Broken waste lines would result in water when flushing a toilet or using a dishwasher or taking a shower, for example, again, introducing water back into these slabs. Sprinklers that are too close to a foundation of a building could contribute to water getting into the building envelope, or even something as simple as rain on a vapor barrier prior to the concrete pour could be actually a big problem when that water tries to migrate through the top of that slab. So again, just keep all the possible ways that moisture can get into a slab in mind. If, say, you're in the middle of a building, there's no indication of moisture, and you're getting a reading, and the building manager or the owner is saying it can't be, explain to them, hey, maybe there's a pipe broke. You may be giving them bad news now, but you're gonna be saving much bigger problems down the road. All right, so I touched on some of the industry standards when I was talking about the manufacturer's install instructions before. I just want to show you the ones that are out there. A lot of you may have heard of ICRI, International Concrete Repair Institute. They have a moisture testing certification program. The ASTM has a standard practice, their F3010. The 2 main ones you're going to come across when it comes to finished flooring is typically going to be the ASTM F1869, which is the calcium chloride test, or the ASTM F2170, which is the relative humidity or the in situ probe test. Sometimes you will see the ASTM D4263, which is a plastic sheet method, and I'll touch on that real quick. I would say the classic car of the moisture tester standings could be considered this ASTM F1869. A lot of you may be familiar with it. It's been around for a long time now. It's served its purpose for sure, but personally myself and a lot of finished flooring companies now do prefer the ASTM F2170, which I'll get into in a little bit. But the ASTM F1869 is certainly a good test. A lot of the problem with this test comes in the human error side of it. What is it? Essentially, you can see here, it's going to be a petri dish of calcium chloride, which almost looks like little styrofoam beads, actually. Those will absorb the moisture vapor that transmits through the concrete within the plastic dome. Tests usually take 60 to 72 hours to get results. They're going to be stated in pounds per 1,000 square feet per 24-hour period. So for example, a finished flooring manufacturer might say something in their language, in their install language, like suitable for use over slabs up to 7 pounds of moisture vapor emission when measured in accordance with ASTM F1869. So when doing this calcium chloride test, that's going to be the result that you're looking for as a max. Anything up to 7 pounds is going to be okay. Some things to point out with this test, and this is going to be essentially for any moisture mitigation test that's out there right now. The building must be completely enclosed, acclimated with working HVAC in place, which means that space has to be fully acclimated and essentially in the condition that you're going to be leaving it in when the room is in service. And as I mentioned before, this is not a test recommended for exterior use. So as I've been saying throughout this presentation, you want to look for these moisture problems early. The fact alone that the HVAC has to be in place does make it tough to bring these things to light sooner than later. A lot of times they don't enclose these buildings until well after the construction starts. They don't fire up the HVAC until maybe a week or two before the building opens. Your test is essentially invalid until it is in HVAC condition. A couple other things to point out with this test and potential shortcomings, like I said, with the human error side. You could see here around this square that floor is actually ground down to clean concrete, okay? A lot of people don't read the instructions on these. They go in there, they might take like a light piece of sandpaper and say it's clean. You have to expose the pores, get essentially that top skin off of that concrete to make these tests even have a chance of working right. Once you do that, you see here you put this little dome over it, okay? You're going to take the lid off, put the open petri dish inside under this dome. They're going to have a little tape border around it. You put them down. Now you walk away. You're supposed to come back about 72 hours later, and then you're going to pick up the petri dish, and then we'll get into how you figure out the actual pounds per thousand. But as you can see here, there's a little bit of prep work done. You got to put these domes down, and I can tell you firsthand when you go into a commercial space and you put these things all over a floor, I swear, it's 2 minutes after you walk out the door, they go play soccer with them. I've laid down hundreds of these things, and every time I go back, maybe, I don't know, every 1 out of 10 is still intact. I don't know if they drive forks over them or they kick them on purpose, but it seems to be like a magnet to get ruined. And once that dome seal is broken, the test is invalid right there. The idea here, again, like I said, that moisture wants to reach equilibrium. So you can see here, if you dome it off, when that moisture tries to come out of that slab, it's going to stay in there, soak into those calcium chloride beads, and that's, again, where you're going to get your result from. Okay, here's an example of one after the dome is released. So you can see here, you put your start weight. All right, you can actually get a scale for this, a very detailed scale. And then you can put your start time. So now you know the day and the original weight and the time. You come back in the 72 hours, you pick this up, you weigh it again, and there's an actual equation that you have to do to get to the pounds per thousand, which is going to be your results for this test. So again, another chance for human error. Not saying that it's very hard to do, but the more chances for human error, the more chances for problems. But a lot of people use these just based on the relative inexpensiveness of them compared to some of the other moisture tests that are approved. So you can understand that aspect of it, but some of the other cons also include, it's only going to give you information about the top half of the concrete. So again, as we saw earlier, the moisture in these slabs usually isn't a problem until the floor covering is put over it, okay? So if the snapshot of that flooring is fine at that time, you assume everything is good. You don't know if there's maybe a hole in the vapor barrier below or something like that, which once covered is going to expose itself a lot more as it tries to reach equilibrium. As I said before, they have to be done when the HVAC is installed, since these tests are certainly sensitive to ambient temperature and the RH of the building being tested. And worth pointing out, both of the common standards here that we're talking about are going to require 3 tests for the first 1,000 square feet and 1 additional test for every additional 1,000 square feet. So those add up pretty quickly as well. So I do tell people a lot of times to mention the moisture, but don't just offer to take on the expense or the time to do these tests. If you figure you have a 20,000 square foot building, or I don't know if you're doing a high rise or something like that, they'll add up real quick. Not only taking time to put them down and record them all, but also the money to buy all the tests. Okay, now we'll get into the ASTM F2170, the relative humidity test. This has become the more preferred test in the industry, which you'll be able to see why you have to review this type of test. Now, there is different companies that make these, but pretty much every time you're going to drill a hole to about 40% of the depth of the concrete slab. You're going to place an RH sensor in the hole. You're going to allow this sensor to equilibrate for about 24 hours. And then after about 24 hours, you're going to get a pretty accurate reading of the actual RH or the moisture in that slab. Same thing, building must be completely enclosed and acclimated with working HVAC for 48 hours prior to the test taking place. And then obviously all the way through the test being conducted, which, as you can imagine, does not make this a valid test exterior. It is worth pointing out, though, read the instructions for the people that make these type of tests. A lot of them will say if it's not an HVAC condition, within 24 hours, you may be within 5% of the actual RH reading of the slab or something like that. I point this out because it is still beneficial to drop these things sooner than later if you can. So if the building's not even in HVAC condition, but say you're scheduled to come on the job in a month from now, you drop one of these tests and you're getting a reading of 99%, you can be 100% sure that that slab is not going to reduce to 85%, say, if that's what the floor covering you're putting in requires. So again, you can see why this is important to drop sooner than later. So these ones are going to be a lot more accuracy if the building's not in service condition compared to the calcium chloride test that I just reviewed. So after you drill that 40% of the depth, you're going to put that probe into the slab, sit 24 hours. After that time, you're going to come back and you're going to take your actual reading. You're going to take your meter and put it in there and read, okay? The brand that we're showing here is going to show you the temperature of the slab and also the relative humidity in that slab. So if it's at 95%, it's going to literally show you 95 right there. You can bring the super, the owner, whoever over, and show them that the moisture is actually at a reading. It's not just some little petri dish equation that you're doing. So as you can see why it's becoming more accepted in the industry as a valid source. And off to the right of this slide, this is giving you a great example of how it's more accurate to get 40% into the depth of that slab than the calcium chloride test, which just sits on top. Let me get into the ASTM D4263, the plastic sheet method. I don't want to minimize this test, but it's essentially a poor man's moisture test. I tell people a lot of times if they're concerned about moisture before they go into a job and the homeowner doesn't want to hear about it, or the building owner doesn't want to hear about it and they don't want to pay for any moisture testing, drop a plastic sheet down, tape off the edges, let it sit for 18, 24 hours. If you see water building up under there, you could easily tell them that that same thing's going to happen under the flooring that you're putting down, and you can imagine what problems that's going to cause. So again, this isn't going to give you the readings that these finished flooring companies are going to want for you before you put your flooring down, but it's certainly a good way to bring up the topic sooner than later and show someone that there's a potential problem there. Now let's get into preparing the floor for the mitigation product that you're going to be putting down. I can make an entire webinar out of going down just this document here, but I will save you a lot of time today by telling you to just go to and refer to our TDS 230N, which is going to be our substrate preparation and primer guide for LATICRETE self-leveling products. This is going to be an extremely detailed and complete guide on how to prepare these floors before putting the products down. It'll get into how to go over different substrates, how to prepare those substrates, and anything else that you need to be concerned with before putting these products down, whether it's priming, shot blasting, you name it. I'd highly recommend you reading this document before you do any moisture mitigation or self-leveling install. All right, now that you know about the prep and primer guide, let's go through some of the main points that document is going to give you so you can actually visualize it and see it firsthand. The main thing you want to look for any substructure or subfloor that you're going over is that it's clean, sound, and solid. That means all surfaces must be free of any dirt, dust, oil, grease, wax, standing water, coatings, paint, curing compounds, sealers, adhesive residue. If it's on there, it's got to go. That could be a potential bond breaker for whatever you're putting over it. As you'll see in that prep and primer guide, we're always going to want you to remove these contaminants and create a CSP, which is a concrete surface profile. Never chemicals, no acids, okay? Acids, cleaning agents, stuff like that can change the pH or the composition of the concrete. They can create a weak bondable layer that is brittle or not well enough to receive the moisture mitigation product over it. They don't increase the surface area, which again makes it better to bond to. Long story short, they can adversely react with whatever subsequent layer is going over it. So what do I mean when I say remove these contaminants, create a CSP? In addition to not using acids, if there is dust or debris or something like that, never use sweeping compounds over these products, over a concrete slab. If you have a super or an owner or someone like that that says they're going to sweep the floor before you come in, ask them what they're using. You never want to have a sweeping compound used. If you don't know what a sweeping compound is, it's essentially a bag product that you could pour over it. It looks like almost like little beads. It has oils in it that actually soak up that dust and make it easier to sweep up. It doesn't allow that dust to go airborne, obviously important in buildings. But those oils will soak into the slab, which will in hand make a bond breaker for the product that you're putting over it. One of the big ones that I said before too is sealers, right? You want to make sure there's no sealers present. So that concrete slab could look perfectly clean, sound, solid, but there could be a sealer on it that could also be a bond breaker. So again, you can see why creating a CSP is important here. It's going to better assure that you remove any sealers from that slab, even if you don't see them. A good way to look for invisible sealers is a simple water drop test. You can see here to the right, there's some beads of water on the slab. Essentially what a water drop test is going to do, flex some water onto the slab. If it's high suction, that water is going to completely absorb in about 15 seconds. Usually a good indicator that there's no sealer. Normal suction, you're looking at about 30 seconds, no less than 15. Still not a big deal. Non-suction, that water is going to beat up and does not absorb in 30 seconds. So if you drop some water on that slab and it doesn't go anywhere, you know that something's there, which again would be a bond breaker for the product going over it. So how do you get a concrete surface profile? Types of machines and methods. You can see here the CSP of 3 is usually ideal for a moisture mitigation layer going over it. Read the manufacturer of the product that you're installing's instructions though. Ours is usually going to be able to get away with a 1 to a 3. Again, as long as there's no sealers or something like that in the slab. 3 ideally is what you're going to be shooting for, which is a light shot blast. So the methods of machines, shot blasting like I just said, dustless grinding, scarification or scabblers, power washers, or even sandblasting are ways to profile a concrete floor. Here's some of the equipment and what it looks like. Grinding. You can see here we got a little edge grinder. In the middle we have a hand grinder, angle grinder. And on the side we have a diamond grinder. That's going to be a big commercial guy that's grinding floors all day. That machine will save you a lot of time on jobs like that. A lot of guys though, if they're just doing rooms here and there, they actually just use the hand grinder and have no problem. We do in the industry actually does prefer those shot blasting. That's going to be your most consistent way to mechanically remove the contaminants. It actually uses shot beads that bombard the concrete. They almost look like little BBs, which you'll see in a minute. And then they have a vacuum system which basically contains those and removes the debris and recycles the shot and just keeps flowing it back through the machine, pulverizing that floor. This is going to allow you consistent results and easily get you to CSP of 3. The big thing though is that it exposes the fresh concrete and opens the pores, giving you a great surface to adhere to, bond to, put a moisture mitigation layer over. So you can see the difference here in these photos, right? You're going to see the clear, obvious side that was contaminated, and then you see the guy shot blasting. Almost looked like he's mowing the lawn, but you can see it's much cleaner. All those pores are open. All those potential bond breakers are going to be off of the floor and ready for whatever's going on top. So here's what they look like. Shot blasting shot, bead blasting, some people call it. These, again, are going to run through that system and then just go back into the floor. Any beads that don't get off the floor, you're going to have magnetic cleanup tools that'll help with that. These are pretty cool. I call them like the matrix tool. You'll see the little beads try to migrate over to the magnet. It's pretty fun to do. Very important note, do not drop these beads or leave them on the loading dock. If they fall down, it is not a good time. The super, owner, OSHA, everyone's going to be on you. So just don't learn that one the hard way. Don't leave them sitting on the loading dock. Okay, here's a good example too, and why we recommend shot blasting. You can see to the left, the grinding definitely gets it clean. You're back down to clean concrete. You can see to the right, the scarifying also gets it clean. A couple of problems between both. The grinding sometimes, if that diamond that you're using isn't sharp enough or is dull, you're actually being counterproductive. Yes, you are cleaning the slab, but at the same time, you're burning it to the point where you're closing that slab off, again, which could be a potential bond breaker. And scarifying, although it does get it clean, you could imagine the amount of material that you're wasting. So you'd see in the middle, the reason that shot blasting is recommended so much: consistent results, nice open pores, not using too much material, and you don't have the potential effect of grinding it off and making it closed again. Okay, so now we have the slab clean, sound, and solid. There's no contaminants, surface temp is right, ambient temp is right, there's no debris on the floor, we got the proper CSP. We're ready to apply the mitigation coating. As with any product you're going to install, it's important to keep it in a controlled temperature before installing. Always read the label of the product you're installing. Most of these products, from the minimum dry time up to the 24-hour window, you're going to want to put that self-leveling or the next coating over it in that time. A lot of times after that 24-hour window, it's just the nature of epoxies. They're going to close themselves off and not be able to receive the successive coating. So you're either going to have to reprime or reapply the product. Just keep that in mind, that the crews are ready and you schedule these jobs in succession. So you don't just put you don't put the mitigation down one day and plan on coming back next week to put the next layer over. It's not going to work out good for you. Also, make sure you have your tools ready to go. So you're going to want to get your mill gauge, your drill, and you'll be able to see these tools, and we'll go over them a little more when we do the hands-on demo portion. Before we get into the actual mixing of the product, though, I just want to go over what's actually going to happen and how these moisture mitigation products are going to help with the actual moisture affecting the finished flooring above it. As I showed you earlier, the moisture coming out of that slab is not a big deal until you cover it with the floor covering. What this moisture mitigation product is going to do, it's going to go on top of that slab. It's going to dry on there. It's not going to stop that moisture from going through. It's actually going to let that moisture go through at a perm rate, which is a rate that's allowable and doesn't affect the finished flooring above it. I usually describe this: picture a toll booth when you're driving on the highway. You're always going the speed limit, right? But when you get up to the toll booth, you're going to have to slow down to make it through that toll booth. So that's kind of what's happening here with these mitigation products. It's allowing that moisture to pass through, but not at a speed that's going to affect the flooring or the coating above it. Okay, so now we're ready to mix the product. You can see here we have the part B behind and the part A pail. You're going to essentially pour the A into the higher filled B. You're going to mix the epoxy resins and blend them well so that there's no ribbons and they're uniformly mixed, usually about 2 minutes. Always read the label of the product you're installing. You're always going to want to pour out the contents immediately onto the substrate in ribbons. For our Vapor Band Primary R, which we're going to feature today, for example, you're going to have about a 30-minute open time on the floor, but if you leave that product in the pail, you're looking at about 10 to 15 minutes. So get those ribbons out on the floor. So you'll see here, you're going to combine the resins, blend them well, and then you're going to pour out these ribbons onto the substrate. Like I mentioned, the heat table is important. Get it out onto the floor. Don't leave it in the pail. And then most of the time, if you're doing a big job especially, people are going to use the notch squeegee. This just helps distribute the material evenly. So one guy can go around pushing the material, and you could have someone in his spikes following him and just back rolling, making sure that you have the correct mill thickness, and you're good to keep moving. If you don't have a notch squeegee, a lot of people don't use them. I usually tell people, if you don't have one, read the packaging of the product that you're installing, see how many square feet per unit you're getting, and map out that size area, and then make sure if you're just rolling it that you roll all the product out to fit that area. That's going to usually give you a pretty good mill thickness, and you're going to get the right coverage for the product that you're installing. So if the product says it can do 240 feet, map out 240 feet, roll it out to that square footage, and then move on to the next pail. As you can see here, you're going to want to back roll the material after the notch squeegee with a high quality 3/8 inch non-shedding roller. Non-shedding is important. You don't want one that's going to just keep falling off and leave the flex in the moisture mitigation layer, which again could be a bond breaker. So now you know what you're looking for as far as preparation, tools, mixing, installation. The only other thing really worth mentioning at this level is if You're putting a self-leveling over the floor that's not going to be covered with floor covering, say a wear layer, polishable overlay, wearable topping, whatever they call them. Something like our NXT Level SP or NXT Level DL, for example. You're going to want to do a sand broadcast in the moisture mitigation while it's still wet. We'll go over that in the live demo portion, but here's an example of it. What this is going to do, it's greatly going to reduce the map cracking, which you can see to the right. The way these products dry, they're going to want a tensile pull off the floor as they dry. If they don't have this sand layer, that map cracking is guaranteed to happen and is usually something that the end user is not going to want to see with their polishable topping or exposed wear layer. Okay, now you guys are experts. Let's get into the products. The one we're going to feature today in our live demo portion coming up soon is going to be our Vapor Band Primer ER, which is for epoxy rapid. This is a revolutionary product in the industry. Okay, this is the first product that allows you to get mitigation and priming out of the same product. All right, a lot of other companies have rapid drying moisture mitigation products. No one can say that they have a product that can be the primer and mitigation in one layer. This is going to save you a ton of time on the job. You can imagine other products, you're going to have to put the mitigation layer down. You're going to have to wait for it to dry. You're going to have to come back and put a primer layer down and then have to wait for that to dry. You're essentially adding a day to the schedule. This product here is going to take a day off every single time you use it. Imagine on a large job what that could do to the schedule moving forward. Another good benefit about this product, it can be applied over new concrete in as little as 5 days. So you see these buildings becoming more fast track. 5 days after that concrete is poured, you're able to install this product over it and keep that job moving. This can handle up to 25 pounds of pressure, like we were talking on the calcium chloride test, and can handle up to 100% RH, 14 pH. These are extremely high numbers in the industry, and it is going to meet the ASTM F3010 standard. When I say up to 100% RH, what do I mean? No standing water. So as long as there's no puddles or anything like that on the floor, it's prepared well, you can install this product over it. And I just want to emphasize again, you do not have to prime this product after it's dry before installing self-leveling over it. Another product in our line, the Vapor Band Primer ER, certainly being the premium product, it's going to save a ton of time on the schedule, is our NXT Vapor Reduction Coating. Great product. It's going to give you that moisture mitigation benefit, certainly. A couple of the pitfalls on this one compared to the Vapor Band Primer ER is that you do have to prime over it before installing self-leveling, which you'll see how to do in that prep and primer guide, in addition to it also taking a little longer to dry. So you're looking at about a 12-hour dry time on this product. So if time isn't crucial on the job and budget's more of a concern, this is certainly a great product that'll also handle the moisture mitigation in those spaces. Joints and cracks is another one of those topics that I could spend a whole webinar on doing. I just want to point out to you, again, that prep and primer guide is going to tell you how to address these expansion joints, control joints, movement joints, and cracks to the T. Follow these instructions. There's industry guidelines, all that stuff to follow. You do want to always treat these, though, before putting the mitigation layer down. This is not something you want to put the mitigation layer down and then figure out after how you want to treat them. You want to close these off and get them ready for the mitigation layer before it goes down. With a product that can handle moisture, too, obviously. Keep that in mind. Typically, it's going to be a mixture of the mitigation product mixed with a ratio of sand. You're going to get it in those cracks. It's going to fill those up and make a nice bondable surface for the moisture mitigation product when they go over these cracks. Another thing to mention, touch on, is the dew point. We have a TDS on our website, TDS 166, which goes over the effects of dew point temperature on flooring installations. Review this document. It's going to explain this very well. But the main thing you want to think here is the principle of, say, the dew on the grass when you go outside, right? You do not want to be installing these coatings if the space that you're installing them is at the point of dew point. So just check that out. It's very simple to do. Just keep it in mind. We're going to get into the hands-on portion here in a minute. Just a quick recap. We went over the concrete design, the ways that moisture can affect that concrete, the types of floorings that can be affected by the moisture in this concrete, proper preparation, proper mix and installation, and then proper curing and successive installations over the moisture mitigation layer for the next product going over it. And just to touch on it real quick here in the moisture mitigation portion of it, we do have these products under two different options. Our NXT line is going to be your everyday moisture mitigation, self-leveling, basic skim coat, flash patch type products. Pumpable, certainly large-scale commercial jobs, but if you ever have the opportunity to get a job that's colossal, we also have our Super Cap Ready Mix option, or if you really get into the scope of work, we have companies that actually have their own trucks. What this is going to do essentially is give you a mobile mixing station, which you can pull up to the project outside. You're going to be able to pump this self-leveling in the building. So if you're going to be doing one of those scale type jobs, you are going to want to use the Super Cap mitigation in conjunction with the Super Cap self-leveling underlayment or pourable polishable overlay type product. Thank you very much for taking the time to watch this presentation. I hope you learned a lot. Don't ever hesitate to reach out to us or your local rep. We are always glad to help, and I think it's one thing that sets us apart from the competition immensely. Now let's go get into the hands-on portion of the demo.
Wow, Marcel, thank you so much for all that information in such a short amount of time. You must run a lot of marathons.
I wish.
Is there any points or questions that you'd like to emphasize while I get our next presentation loaded?
No, not really. We had one in the chat. I just want to, clarify it for people. And again, if you have any additional questions, don't hesitate to reach back out to us. It was about going over like a roof deck or something like that, essentially with the tar on it. Unfortunately, this stuff, the mitigation products that, help the mitigation are going to be over clean, sound, solid concrete. That's really all they're made to help with. They're not waterproofing from the top down, if that makes sense. So they're not going to hold water in. We're not going to say they're going to hold water in like a shower would or a pool. They're to stop, again, that hydrostatic pressure from going up through the floor, through the slab at a rate that will hurt the flooring. So anything like that would be considered unsuitable, kind of outside of this scope of work. But at that point, you're doing our plaza and deck system, which I put a link to on there. You're almost building a new, if you want to think of it, mini independent slab over that unsuitable surface. I did mention it's going to have like a drainage system on a roof, especially. Main thing is you don't want that water building up in that mud bed sitting there. You can imagine the weight that's going to add to the roof, the microbial growth and stuff like that over time. So two different spectrums. And one thing to point out, self levelers in our line, I don't know many that have any that can really go outside. That's typically going to be an interior application. And again, moisture mitigation, it's handling hydrostatic pressure, not flood water. So two different applications, but long story short, you're going to have to build something new over that.
Gotcha. Well, thank you so very much.
Or remove it down to a suitable substrate if that's the case. So.
Got it. All right, so let's move on to our next section, which will be our product demonstration video. This is a shorter video. This is about 11 minutes. So I will start sharing my screen with you all, and let's get it going. Ooh. I apologize. Hang on. I'm losing the controls here. Oh, there we go.
How are we doing, everybody? Marcel at LATICRETE Tech Service. All right, so we just went over the presentation portion of the moisture mitigation. Now I'm going to get into some of the tooling, mixing application, okay? First tool, a lot of people are going to use this in the field, a notch squeegee, as we mentioned. You're going to cut out the ridges of the notches in this squeegee to fit the product you're putting down. So 16 mil, guys are going to put a little bigger notches, 12 mil, smaller. There is some companies that make these, but just keep it in mind that this is going to make it a lot easier to spread the material. It's going to allow you to get it out in a nice even coat, make the back rolling a lot easier, keep that install moving faster, okay? Next big tool, obviously, is the roller. Nice 3/8 nap, non-shedding roller. We do recommend to put some blue tape on here before. When you pull it off, it is going to take any of that shed that would come off that might go into the product, which is in hand going to make it easier to bond when you put the self-leveling or the next coat over it. Naturally, you're going to want a little edge brush, chip brush, when you're going around pipes, walls, stuff like that. Definitely an important tool to have on the job. And then the wet film thickness gauge. This is the big one. If you're using a product that needs 16 mils, we'll show you how to use this later. This is going to allow you to dial into the proper thickness, making sure you're getting the right coverage and also the right performance out of the product. And then obviously a drill. You want a low-speed drill, nothing crazy. You don't want a cement drill, some high-powered thing. You're trying to get a nice even mix of the product in the pail. You don't want to get too much air into that product. Nice low-speed drill, you're good to go. So now we're going to go over the mixing of the product. Again, today we're going to be using the Vapor Band Primer ER. This is our premium moisture mitigation product. Again, it's going to go down, allow you within about 3 to 4 hours usually to pour your self-leveling right over it without priming. Huge, huge game changer in the industry. Okay, now that we show you the tooling, I'm going to get into mixing the product. So now we're going to mix the material. So we'll take our lids off. I usually suggest using a hammer. That's going to help get those edges up. Just makes it easier to take the top off when you're in the field, so you're doing 20,000 feet. Keeps it moving a little bit. So if you can see here, you're going to have your Part B contents. We're going to get our Part A open. Take the top off. Okay. All right. So now we are going to take our full contents of Part A, get it into the Part B pail. You can see it's bigger for the mixing. Very important, make sure you get all of the contents of Part A out of the pail and into the B. Okay. Now keep in mind, you're gonna have about a 10 to 15 minute pot life, okay? So make sure this stuff gets in there, get all the contents part A in, and then start mixing. So you can see here, take that time to get it out. Put that off to the side. Now we're gonna get mixing. Again, low speed mixer when you're doing this. You don't want too much air getting introduced into the product. So you can see here, just want to get a nice uniform mix. You're going to see the ribbons start in this product. This is what you're looking for. So you can see here, I'm keeping it moving around, making sure I'm getting a nice uniform mix. You're going to want to mix this for about 2 minutes. The time of mixing is very important with this product. You'll do jobs where people will say, well, one section's fine, the next section's not. If you really look back at it, it's usually from that they didn't mix it too long in the parts that are bad. So you can see here, it's getting a nice uniform consistency. You don't see any ribbons. A and B is blended together nicely. We're about ready to put this on the floor. Okay, now we're going to actually get the product onto our simulated slab here. One thing always worth mentioning, make sure you have the proper PPE on, depending on the job site rules. Obviously nowadays, follow any standard guidelines in your local municipality. But we're going to get the product out on the floor. Another tool that we didn't go over the initial round of tools is going to be your spikes, okay? These are going to help you, as you're moving that material around, when you step into the material, the pins on the end of those spikes are not going to hurt that material. It's going to heal back over it and still give you the moisture mitigation capabilities that you're looking for. So, for today's reason, we're not going to put them on because we have cement board down here. I'll probably go right through it. But on a job, you're definitely going to want these. These are your good friend. All right, so now getting the material out on the floor. Very important to point out. The pot life on this is going to be 10 to 15 minutes. The open time is 30 minutes, so keep that in mind when using the product. If you're doing a big area, all right, make sure you get that material out of the bucket fast. You don't want to leave it in there. It's going to start to heat up. Don't throw it in a dumpster like that. You can start a dumpster fire. Just something to point out.
Okay. Which way do you want the ribbons to go?
I'll just go here and then back.
All right, so Gilles is going to pour out the material. Again, making sure you get it out of the bucket, onto the floor. That heat table for epoxy is going to be a lot better on the floor than in the bucket like I just mentioned. So just to give you an example, with the squeegee here, this is what it's going to look like. If you have the notches, you're going to pull across. You can see here, it just makes it easier to get that around. So you'll have one guy moving with the notch squeegee, and then the next person right behind him back rolling. If you don't have the squeegee, or say it's a smaller job, I usually tell people to map out the product's coverage. So for this, you're going to get approximately 240 square feet or so. If you map out that size area on a big job and make sure you disperse this product in that area, that's going to give you pretty good coverage. So again, you see I'm just moving it around. And then on a big job, ideally, back roller is going to be right in with you with his cleats on, and then we're going to be rolling this product up. So again, normally on a job site we'd have our spikes on, and we'd be going in succession. You'd see here, Joe's giving me the idea of back rolling.
So the first thing I'm going to do before I start back rolling is load up my roller, making sure that this thing is full of material so that I don't end up dragging and taking away material as this thing loads up. So this way you get a nice even coat. And I'm also going to be back rolling perpendicular to Marcel's ribbons. This way you kind of have a cross-hatch pattern. Again, ensuring full coverage, full and even coverage.
All right, so as you can see here, Joe's doing the back rolling. This is where you're going to have someone periodically come in and check the mill gauge thickness, right? The wet film thickness. So for this product, you're going to want 16 mils. You're going to dip this in the product. If you're at the right thickness, it's only going to hit that 16 mils on the mill gauge thickness. And as you can see, as Gilles moving it around, you want to get a nice uniform coat, but it does have its own healing properties. So it doesn't have to be perfect like if you were painting a wall for a flat finish or something. You want to get it out, the right thickness, and then it's going to heal to its, to where it's going to go, to heal to its level. All right, as you can see, nice uniform thickness, 3 to 4 hours, depending on the condition of the space, you should be able to pour on that product. As I mentioned in the presentation, if you go past 24 hours, you are going to want to reprime, put another coat on, you name it. Once you pass that 24-hour window, this product is going to close itself off to being able to be poured over without priming. So just keep that in mind. You want to do it after that 3-4 hour range, but before the 24-hour mark. So now, this would be normal self-leveling application. You got tile going over the top of it. So when this is dry, you put our NXT Level Plus over it. If you're using a product like our NXT Level DL or the SP, which is going to give you a little salt and pepper finish, you're going to want to sand broadcast before you put that material down. So just want to show you what that's going to look like. Okay? The main thing, like I mentioned, you're going to want to do this like chicken feeding to the point of refusal. So you actually want to make that floor look like a beach. You don't want to have any wet material showing through. If you do, you're going to put it back on top, which you'll see here in a minute. So like I say, chicken feed. You want to get this up in the air, right? So it's kind of falling down. You don't want to shoot it at the floor. That can move that around to the point where it doesn't mitigate the floor anymore. So up in the air, get it falling down. I'm just going to do 1/2 today. Again, this is showing if you're going to put a wear layer over the top. What this is going to do, as I mentioned, this is going to greatly minimize the mat cracking that you'll get on those types of finished floorings. As we'll go into when we get into the self-leveling products, the way those things dry, they're going to want to mat crack if they don't have the sand broadcast underneath. Couple of points to make on this part of the job. Make sure you have enough sand. Don't be afraid to put too much down. You can reuse what doesn't stick to the floor. So you nicely sweep it off, put it in a corner, and you can reuse that sand at a later date. So example, you can see here, it's a little wet showing through. You're going to want to cover that up. Again, point of refusal. That's what you're looking for. And obviously at a job, we would get tighter to the edges, but I just wanted to show you how it looks. Okay, so we have the sand broadcast down. We're going to let that dry into the material, and you'll see what we're going to do when we come back. We'll be able to get that all off. You have a nice floor ready for a finished wear surface. All right, so I left this here on purpose. Good example of what I was talking about. Do not leave this product in the bucket. You can see it's actually smoking here, right? You throw this into a dumpster, you can imagine what that could do on a job site. So make sure you're very aware of how this product acts in the bucket. I always tell people get it out on the floor. Again, that heat table is better on the floor than it is in the bucket. So we waited about 4 hours. The Vapor Band Primer ER is dry. So now I'm going to show you real quick how to get this sand broadcast off. All right, nice stiff bristle broom. Just going to brush it into piles. Take it right off the floor. Anything that you're able to get off with a broom, you're going to be able to keep. Okay. Some people do a light scraper on this, usually not necessary if they have a good high power vacuum. The idea though is you want a finished product that's almost like a sandpaper finish, which we're going to show you in a bit. So we have the sand broadcast cleaned off. No loose sand on here. You can hear as I go over it, you have basically the texture of a sandpaper here. That's going to give you a nice base to pour a self-leveler over, finish topping, something like our NXT Level DL, our SP. This is what you're going to want to do every time.
And again, it's going to prevent that map cracking from happening on the top of the surface. Thank you very much for joining our moisture mitigation segment. Main things to remember, prep is going to be everything with that stuff. Okay, you also want to make sure you mix it for the right amount of time. Read the pail. If it says 5 minutes, go the full 5 minutes. And then the last thing is make sure you have the right coverage. Check your mill thickness, so at least you know you're mapping out the right square footage. Thank you very much. Have a great rest of the day.
All right. Thank you so much, Marcel. That was a great video.
Thank you.
Now you're already back home.
Yeah, look at that.
Watching movies. So were there any questions during the video?
No. So we had, I don't know if everyone saw it. I think they did. I saw one on if you can go over our mitigations once dry with Hydroban. You can. That we have tested that. We stand by that. So that's certainly, again, another time saver in the industry. Great question, though, too, because I want to point that out about the Hydroban, right? What I was getting at before, this is hydrostatic pressure. Hydroban would be what I was saying earlier, what you would use for the keeping the water in. So showers, pools. So a lot of people will get those confused. We do get calls from time to time. I used your Hydroban in a basement to mitigate it, and it blew off the floor. Well, you used it wrong. All right, it's to keep water in, not stop it from coming through the slab. So worth pointing out for sure. I just saw another one come in here, so let me.
Yeah, we actually have a question from Chris Billyvo.
You got it. So
Chris, I hope
cleanup.
that's how you pronounce your last name. I apologize if I butchered it. Any concerns or techniques for tool cleanup?
Yep. So really, what you're doing, if the stuff does get time to get on there, it's gonna dry. So you do want to. It's water cleanable when it's wet. So certainly keep it moving. If you are on a large job and you're worried about, say, areas drying on your tools, you might want to keep a couple of, rollers and stuff moving. Kind of map them out as you're going throughout the job. Certainly worth anything like this. You do want to plan it out. Make sure, like you said, you have the right tools. Don't do 20,000 feet with one roller. And then for cleanup, again, water cleanable when wet. Some people, you can use, depending on the building codes and everything locally, acetone or the usual stuff we would use. But as always, with anything worth noting, especially nowadays, proper PPE though. So no matter what, don't skip those steps, wear the gloves and you name it. So.
Another good question we had from Lane in our chat window was about using spiked shoes on an actual job to spread the sand.
Yep. Yeah, so definitely you're going to want to do, that, the main idea, if you're standing out of it, you don't have to. If you're able to keep guys on the side and just spread it that way, you don't have to, but never a bad idea when walking with this stuff. You want to minimize any of those holes actually, being present when you go to put the flooring down, because they will, especially if there's excessive moisture, they'll rear their ugly head. So never a bad idea with that. Same thing when you're self-leveling. You're going to want to usually wear spikes. When self-leveling over moisture mitigation, a lot will wear more like softball type rubber cleats. So you're not potentially puncturing that mitigation layer, but anytime with the stuff, never a bad idea to have the spikes around. Yep.
Great points. Thank you, Marcel. I don't see any other questions here. We have about 3 minutes to go, so I think I'm just going to quickly wrap it up. So first and foremost, I hope everyone enjoyed the content and the format this was in. If you have any further questions down the line, a lot of times I can't think of questions until the next day. So if you're more like me and you want to ask further questions about this subject, do not hesitate to reach out to our technical services department. If you go to our website, you can find the many ways with which you can actually reach us, either by chat or mail or telephone, whatever you're more comfortable. Please do not hesitate to do so. Marcel, I really want to thank you for taking the time out of your day. This was a lot of information, a lot of excellent content. So thank you very much for that. And of course, to all our participants for joining us this afternoon. Again, I hope you found this informative and educational. I thank you very much for spending the time out of your busy day to be here. And I wish everyone a great afternoon, a fantastic weekend. And I would just like to say that this is part 1. We will have another self-leveling underlayment webinar in a couple of weeks. So expect another invitation in your inbox. And on this note, I thank you all again. I wish you a fantastic weekend. Be safe, have fun. Take care, guys.
Thank you all. All right, have a good weekend.
Bye-bye.